All right. So it says convert the equation to standard form of a parabola and then graph the parabola focus and directrix. So they've given us a clue, but you may not know what the clue is. What I want you to see here is, and like I said before we started recording this video, we have to make a decision. The first decision that we have to make is it going to be vertical or is it going to be horizontal? So the equation, what do you guys notice about the equation? It is equal to 0. That's good. What else? 2 x's and 2 4's. So what I really want to hone in on is in all of these parabolas, something is going to be squared. Either the y will be squared or the x will be squared. In this case, the x is squared. So then we look over here. What do you notice about this one? The y is squared. Is it this one? No. So we don't need the horizontal. That isn't going to help us. It's this one because the x is squared. So now we can, they tell us isolate x and then complete the square on x. So we know how to do this. Okay. So let's do that real quick, and then hopefully we'll have some information. So to isolate the x, the first thing we're going to do is we're going to put the y's on one side. Basically, we're going to get all the x's on one side and then move everything else to the other side. So I'm going to start with, and you guys should write this down, x squared minus 4x. We're going to do a little bit of algebra. Minus 4y plus 12 equals 0. So anything that doesn't have an x in it, we're going to move to the other side. In other words, I'm going to add 4y. That doesn't have an x in it. And the 12 doesn't have an x in it. But remember, whatever I do to one side, I have to do to the other. Okay? Well, then that leaves me over here with x squared minus 4x equals 4y minus 12. Okay? Now, they said we need to complete the square, right? So to complete the square, because the reason we need to complete the square is we want the left-hand side of the equal sign to look like this. So if I can make it look like this, this should kind of fall into place, okay? So to make it look like that, I'm going to complete the square, and then it'll eventually look like this up here. So to complete the square, remember, I got to look at this as a equals 1 and b equals -4, because when we complete the square, we are going to, well, let me write this out. I'm going to say x squared minus 4x. Then I'm going to add something is equal to 4y minus 12. But whatever I add has to be, what I'm going to add is b over 2, whatever that is, squared. So my b term is -4. So then I'm going to add -4 over 2 squared. So now when I do that, -2 is what that fraction reduces down to, squared. All right, now this is important. Keep that in mind. Whatever I have in the parentheses is what I'm adding. So I'm going to add -2 squared. Well, what's -2 times -2? +4, right? So when I say -2 squared, that means I'm going to say -2 times -2. That's equal to a +4. So what I want you to see is that this is the same as this. You guys on board with that? Yeah, sorry. Let me zoom out a little bit. Okay? So now, in the next step, I know for a fact that if I take x minus 2 and square it, that's the same as x minus 2 times x minus 2. And I'm going to move over here a little bit. When I square something, if I say x minus 2 times the quantity x minus 2, then this becomes x squared. Negative 2 times x is negative 2x. Negative 2 times x is negative 2x. What's negative 2 times negative 2? Negative 2 times negative 2 is a positive 4. If I combine like terms, this one and this one, this is equal to x squared minus 4x plus 4. Now, what I'm saying is that this equals this. In other words, this line right here, x squared minus 4x plus 4, okay, that's equal to 4y. What's negative 12 plus 4? Other way around. Opposite signs, it'd be positive or negative 8. Now, here's the thing I want to encourage you guys. It's very easy, and Mr. Adams makes these mistakes all the time because we do a lot of math every day, and sometimes we just kind of plug away. Just do it on the calculator to make sure you're right. Say negative 12 plus 4, and it's negative 8. It's okay. I'm good with it. I am okay with you guys using your calculators. It's helpful. So now, but what did I do? Well, I said that is equal to x minus 2. Well, how did I know that? Well, it's this and this. It's the square root of this and the square root of this. In other words, it's x minus 2 squared. All of that is equal to 4y minus 8. Now, here's the interesting thing. I'm going to let you guys write that down. I'm going to give you a second to write that down. Does that sort of look like the standard form for a parabola? Yeah, so if I zoom out, this little, it's starting to look like this, right? What do I have to do to make it look like this? I can zoom in, I guess. What do I have to do to make it look like this? This stuff over here. What do I got to do to make it look like that? What do I have to do to make it look like that? Yeah, I got to factor out the 4, right? So to make it look like that, I'm going to have to take this and factor out a 4. In other words, I'm going to think to myself, and you could factor out anything, but yeah, I need to make it look like 4p. Let me write that down so it makes sense. I need to make it look like x minus h squared is equal to 4 times p times the quantity y minus k. I need to make it look like that, okay? I need to make it look like that. So how do I do that? Well, I got to do some work over here. I got to make this look more like this. In other words, I've got to isolate the y. I got to get y by itself. Now, the problem's rigged up in the sense that if I factor out a 4 and I do the distributive property backwards, what's 4 times y? 4y. What's 4 times negative 2? Negative 8. So this whole thing changes to 4 times the quantity y minus 2. Everything else stays the same. X minus 2 squared is equal to this stuff. Well, there's got to be a p in here somewhere, so this, whatever this is, whatever is in front of the y minus k, that has to be set equal to 4p, right? because that's the formula. In other words, this stuff in the box has to equal this stuff in the box. So I set them equal, and then I solve. 4 divided by 4 equals 1. In other words, P equals 1. Well, what's my H and K? Well, H is equal to whatever this value is, 2. K is equal to whatever this value is, right here, right? K, K, H, H. And I have P. So now that I have P and H and K, I can find the focus. What's the focus? Well, the focus is H, comma, K plus P. Well, there's a lot of information here, so let's do the focus. So the focus is H, comma, K plus P. Well, then what's H? H is just 2, comma, what's K? 2 plus P, what's P? 1. So then the focus is 2, comma, 3. Now the vertex is just H, comma, K. Oh, not X. Which is really just 2, comma, 2. And then we need a directrix. So how do I find the directrix? Oh, it's Y equals K minus P, right? So my directrix, I'm going to write that up here because I'm running out of room, is Y equals, I'm getting that information from here, K minus P. What's K? 2 minus P, which is 1. So my directrix is Y equals 2 minus 1, which is 1. All right, let's graph this and see what we get. So you could do this in Desmos. Desmos works best. We'll just do the graphing calculator. And so I said Y, what was some of the stuff I said? Y equals 1. So that's my directrix. Okay. The next one is the focus, which we said occurred at, what was it, 2 comma, what was the focus, guys? Look on your papers. 2 comma 3. Okay. So that was, and we're going to put a label on it, that was the focus. And so all this information I'm just pulling off of the thing. What was the vertex? 2 comma 2. So we'll label this as the vertex. All right, cool. And then we are going to plug in the equation and see if we're right. So x minus 2. So if my equation is right, what will I see? How do I know the equation is right? Yeah, it'll be equidistant, right? It also, that should go through the vertex, right? And it should open up. It should open up because, and we'll look at the table. Let me finish graphing it. So this is 2, and that's equal to 4 times the quantity y minus 2, correct? Look at that. Everything looks legit, right? So a student said that this is equidistant. In other words, this is 1 unit away from the directrix, and the vertex is 1 unit away from the focus. That's the very definition of the focus, right? It's equidistant from the focus to the parabola, and from the parabola to the directrix. So everything looks legit. Let me make a copy of this, then we'll double check it with that table telling us a bunch of information. So I'm going to put this, if I can fit it in here. And we'll zoom in on it. So according to this, does the graph open up or down? It opens up. Now, we need to look at the qualifying statements for that. Well, opens upward means that P is greater than 1. Is P greater than 1, or I mean greater than 0? Yeah, I said what it was. It was 1, right? P equals 1, so it's greater than that. It goes through the vertex, and it's equidistant. So yeah, we're done. That's how it looks. Okay. Are there any questions on that one? Yeah, you want me to zoom out so you can see it better? Yeah, there you go.